There's two drafts on data center benchmarking. We'll mention those really early because they're basically just done. And then another one is part of the agenda on vSwitch benchmarking and OPMC. It's our link to an open source community. Okay, good start.
And then I think the SPM controller one will come through too.
Yes, there's two on those. That's right.
The good news is those are all three of these drafts have been well vetted, well reviewed. They've been here beaten around. Yeah. Yes. We are not generally that type of working group, so yes. Right? We should be your favorite chairs.
All right. Hey, it's after 9 o'clock. I guess we got to get going. All right. Now everybody's been looking at my mail for the last 5 minutes. All right. So here's where we are. Oh, that's because I'm waiting. I'm still waiting for mail from you. But that's okay. Let's send it to the real me.
Okay. Morton, ACM Morton at att.com.
AC Morton at att.com. Yeah, that's the one. All right. Maybe all your stuff is going in the spam folder.
It's possible because when I moved to AWS, there's something because I did a lot of spammers in AWS. It could be going in it's entirely possible.
It could be getting quarantined. Huh?
Here, let me send it to you from my work email, and then it'll be ACM Morton at att.com.
Well, this is great. This is the first projector I've used in a long time that didn't try to make my screen, this big. So I'm really pleased with this. This is awesome.
So fair warning, if you're sitting at the back of the room, go back to that first slide. Yeah, you are subject to being a jabber scribe, a note taker, buying us beer, those things. Yes, please move close. Come on up. We don't bite.
Okay. Are you ready to go?
I'm ready to go. Let's do it.
All right. Okay. Good morning, everybody. This is the Benchmarking Methodology Working Group. Welcome. I'm Al Morton, one of the co-chairs. Sarah Banks, sitting next to me, is the other co-chair.
Hello.
And we're about to start our meeting this morning. We have blue sheets going around. If you haven't signed the blue sheet, let's leave that somewhere where the here Stenio can do it, and then let's leave that where it can be circulated easily. I'm going to try to track the folks coming in and so forth. So if you are, well, you know what? I'm going to wait another 5 minutes or so to ask if you're new question. We're starting to do that, and so that's a good thing. All right, so I'm moving on to slide 2 now for folks playing at home. Slide 2 is the note well. If you have IPR, we'd like that you disclosed it, and there's rules about that here in the IETF. They want you to disclose it promptly. So please be familiar with RFC 5378 and 3979, and as it was updated by 4879. Any questions about the note well? All right, I'll assume everyone's understood. It is Thursday after all, and you should have seen this a few times. So here's our agenda. We have two note takers, Jacob and Ramki. Please put up your hands. If you can, and you're at the microphone, please show these guys your badge, and that way they're most likely to get a correct spelling from the start. That's truly awesome. Jabber is going to be scribed by Jay Karthik right here, and so if you've got a question and you're working remotely, Jay will be the man to help you today. All right. We've done the IPR thing. We've got the blue sheets going around. Stenio, you've passed it, and is it going back there? Who's got the blue sheets? Good. Okay, Bill. Good morning, Bill. So that's good. All right, we've covered the administrivia. So we're starting out with status. We've got the charter and milestones we'll be doing. We have a remote presenter, hopefully. Let's see. Yeah, Marius is in there, so that's good. He's connected. All right. Then we'll hear about the SDN controller performance benchmarking from Sarah, and the vSwitch performance benchmarking in open platform for network function virtualization from me. So that concludes the chartered work that we're going to discuss today. And then, as always, in BMWG, we have many proposals for new work. So we'll begin that with a discussion of network virtualization platforms from Samuel, methodology for virtualization network performance. Is Lou Wang here? Lou? Oh, okay, good morning. And I see Sudin is here to do the performance monitoring and the EVPN, PBB, EVPN drafts. And then we have a brief look planned, if there's time, at the end on microservices on the edge from Ramki Krishnan. Welcome again, Ramki. All right, and then we'll have any other business. Any bashing of the agenda necessary? You'll note that I changed the order of a few topics here. I wanted to try to keep the virtualization stuff all together. And that's not an order of priority, it's an order of mindset. Let's keep our virtualization hats on and then move to the other topics, except for Ramki's. Ramki's is, like I said, has kind of part of all other business. All right, so taken as written. Thank you. And you're welcome. Okay, so now that we've got the doors closed and we're almost 10 minutes into the meeting, now I'll ask, who is new to benchmarking methodology working group? Would you please put up your hands? All right. So even our AD advisor is new. So first off, welcome to everyone who's new to the group. If you're involved in the testing of network devices and network functions, you'll find this is a very easy group to join. I recommend that you take a look at some of our fundamental RFCs, and you'll find out which ones they are because they keep coming up in conversation. 2544, 2889, these are kind of our Bible documents, and from there we've gone on to expand and to benchmark very specific things. So that's my welcome. I think that we'll enjoy hearing from you at the mic and seeing you join our mailing list. There's instructions to do that at the start. So then I want to, as I just mentioned, I want to welcome our new AD advisor, Warren Kamari. And Warren is taking over for Joel. For those of you who are new to and Joel's here too. You guys are perfectly aligned for me. I'm glad you moved. So we have a special situation today of the handoff between Joel and Warren, and so we expect and there's the handoff, the handshaking handoff taking place right there. So thank you for that. So we'll say a few more things about that toward the end, but here we go. So let's move on to the workgroup status, please. And here's the quick version. We've actually got quite a bit of success to report. We had a successful working group last call on the IPv6 neighbor discovery draft, and subsequent IESG approval. That went quite swimmingly well. So we've got that since the last meeting. We also have IESG approval on the VNF and network function virtualization infrastructure considerations draft. This is one we started several years ago. It was the basis for our pivot to looking at virtualized network functions and their infrastructure here in BMWG. And with the existence of that draft, we were able to add this point to our charter, which has really reaped a lot of new work. And like the rest of the industry, that's recognized that benchmarking is cool again because we're trying to do all of this on general purpose platforms. And now the performance of our network devices isn't as simple as counting up the ports and their capacity. So yeah, to be honest, it was getting boring for a while. Now it's cool again. So let's see, we've got revised draft on the data center benchmarking, and in discussions, we think that we're going to call consensus on those. Sarah is the document shepherd, so we'll watch the lists for that. We had a working group last call last year, actually during the meeting, on the OPNFV vSwitch performance draft. So that has finished with no comments, and we'll watch the list for, again, Sarah's shepherd on that one, so we'll watch the list for her call on that. And then we had a working group last call in December on the revised IPv6 transition technologies draft. There were some comments. There was some thought that they might expand it, the authors, that is, and we're going to hear a presentation on that today, so I'll say no more. We've got the revised SDN controller drafts as well after, I think we've had 2 working group last calls on that. And so we'll hear about that again briefly today. But the new work proposals keep coming, and as I showed in the agenda, we've got 5 or 6 of them now. So live and vibrant input to our working group. If you've just come in, ooh,
Uh-oh, I've done a bad thing.
I lost the pen. Oh, thanks. I have no idea where this thing went. It's way under there, and it's black. All right, so no new RFCs, but in a matter of months, we will have a couple, since we've got 2 IESG approved. We haven't made any charter updates. At some point, oh, go ahead.
Next meeting, we're going to update the supplementary BMWG page.
Hooray.
Yes.
That's the next good topic. Yeah. So, thank you. The short version of this is that I was a residential customer on Comcast, and at one point last year, Comcast discontinued web pages for residential customers. So we lost our supplementary page, but I sent all the files to Sarah, and Sarah has kindly agreed to host it on encrypted.net, I think, right? Yes, okay. So that's where the pages are going to end up, and we'll be able to maintain them there. So, like I said, watch this space. So here's our milestones, and there's a lot of doneness here. That's good. We've got, most recently, as I mentioned, the IPv6 neighbor discovery and the benchmarking considerations done. And we're a little bit late on the data center benchmarking to IESG review. And we've got, we're ahead of schedule on v6 transition. I think we can make that one. We're ahead of schedule on SDN controller. I think we can make that. And this last one here is basically the consensus, right? So that's we could easily make this one as well. Very good. So I'm actually pretty pleased about that. That's kind of unique in the working group at IETF World to be on track with this. Although the truth be told, we had to revise a few of these, so let's not applaud ourselves too much. December. What? Yeah. We did finish that. We did finish that one. Yeah. So I mean, it turned out we finished it way ahead of schedule, I think. Or I made a typo in this slide. I found that I did make one in someplace else. Anyway, let's not worry about that. It's done. Okay. So I always take the opportunity to encourage people to use our standard paragraph in the introduction and security, someplace in the draft. It tells the security directorate people that we're working in the laboratory. And if you're seeing a benchmarking methodology draft for the first time, you may not know that our charter is laboratory only. So you may see all this stuff about stressful capacity testing of devices in the network and absolutely flip out. And Warren is seeing this for the first time. And believe me, Warren, it's happened. It's happened more than once. So this is so tuned up for every draft. We encourage people to put this in their drafts, and that way we'll alleviate the potential fire alarm that can come from security folks. And they're much happier that way too. So here's where we stand in the work proposal summary matrix. I try to keep this up to date. We've got a column for every proposal, including the new ones and the old ones, and some that are returning and so forth, and some that we're going to talk about this time. I mean, we'll basically talk about these, but I'll just of note is that we have a liaison out to the ITUT Study Group 15 on the performance monitor benchmarking for Y1731. That's the Ethernet OEM. And that's where Study Group 15 is the place that owns this protocol now. So we have a liaison out to them, and we'll discuss some of that later. So we can see some progress on some of these. And here's one of the new ones we'll be talking about today, virtualized network platform, and a returning one on virtualized network benchmarking. And this has had some discussion on the list. Some key issues have been raised here. So that's where we are with that. Any questions on the work proposal summary matrix? Okay. So seeing none, let's see what's next. Nothing. All right. So we've done our status with the exception of, let's see here, I guess. Oh yeah, I think that basically covers the status of the three drafts that I mentioned here. We've got the data center benchmarking, watch the list, and the other two are approved. So that's it. Okay. And we've done the charter and the milestones. So now we're going to try to go remote for the IPv6 transition benchmarking with Marius Georgescu.
Hello, Al. Can you hear me?
Oh, we can already get.
Yeah, as a presenter, yeah. Well, don't worry, if it gets in queue, I'll let you press the button. We had a big, you guys can nice, we have a big, and that's, don't worry, questions, stuff happens, but there's a big red button up there. You want to put somebody in the queue, press the button. And it actually has a security shield over it, which I'm going to close now, just for safety's sake. That's really cool. That's the best feature.
Oh, thank you.
Go ahead, Sarah. I'll give you the honors.
I am not too fast. That was uneventful. Uneventful. Oh, Marius, are you still there?
I'm here. Can you hear me?
Don't jinx us.
Yeah, we can hear you.
Okay, I hear you too.
I'm bringing your slides up as we speak, as we make fun of the remote presentation system, which is working phenomenally, by the way. So let's see here. Okay. All right. So there's a key combination to make this full screen, I think.
I think it's Control L.
Control L. All right. Let's just try that. Control L. Oh, fantastic. Thank you. All right. I'll be able to remember that for the rest of the meeting. So Marius, the floor is yours. Please proceed.
Okay, thank you, Al. Hello, everyone. My name is Marius Georgescu, and today I will be talking to you about the benchmarking methodology for IPv6 transition technologies draft, which is at 5th iteration, actually. At first, I will be speaking a bit about the draft motivations for people just joining BMWG. Can you move to the next slide, Al, please?
Okay, I have. By the way, Marius, can you see the slides?
Yes, I can see them, and this time around is faster in the switch, because last time it was kind of slow. So,
good.
Yeah, I'm pretty sure everyone in there knows about IPv6 and also about the fact that IPv6 is not backwards compatible. So that means the two protocols need some way of some transition mechanism to talk to each other, and also that means that the internet is actually undergoing a period through which both protocols coexist. And currently, unfortunately, we only have about 9% of users that can use internet over IPv6, and towards that, the IETF has been working, proposing many transition technologies. Next slide, please. So in this slide, you can see a timeline of some of the transition technologies that have been proposed in the IETF, and since the 2000, the diversity has grown a bit, and also the technologies have evolved. For dual stack as a transition mechanism, you can use RFC 2544 or RFC 5180. However, for translation or encapsulation, special recommendations are needed. Next slide, please. So as you saw in the previous slide, there's some diversity in terms of transition technologies. Since some of these technologies have many parts in common, we thought about using a generic classification in order to use those common parts, common traits of the technologies to devise like test setups that can be reused, for example. So we came up with, aside from dual stack, with a categorization, single translation. So as examples, we have NAT64 or IV, double translation, there we have 464XLAT or MAPT. For encapsulation, DS Lite or 6P, 6VP, technologies that work over MPLS. Next slide, please. Yeah, I think you're seeing the slides faster than I'm seeing them.
Yes, I think so.
Yeah,
so it's not as fast as you want.
Yeah, there's a bit of delay there. Okay, so essentially the draft is providing complementary guidelines for RFC 2544 and 5180, and more specifically, we came up with the classification that I just presented, and also calculation formula for the maximum frame rate, since there is difference in the header, and with either translation or encapsulation, you have the header difference there. Also, the draft includes a tentative metric of benchmarking scalability. So we're doing that by actually measuring performance degradation under the stress of multiple network flows. And for stateful IPv6 transition technologies like stateful NAT64, we are proposing additional benchmarks in accordance with the RFC 3511. Also, since DNS64 is a special transition technology that doesn't really fit the generic categories we presented, we treated it separately, and most of the benchmarks we proposed, so namely DNS resolution performance and caching capability as well, was proposed by Professor Gabor Lence, one of the co-authors. Next slide, please. So now, coming to the update overview, so we are at the fifth iteration of the working group draft, and I think we covered, actually in the fifth draft, I think we covered the second working group last call comments. Also by moving continuing the empirical analysis, we found out that for NAT64 specifically, there's no space in the 64 bytes frame for adding the UDP identifier for the frame. So we proposed in this context specifically to have, instead of 64 bytes as first frame size, 84 bytes. Also, we found out by testing that we would like to recommend inserting the identifying tag after the UDP header. Also, we did some more updating on the DNS performance caching after Gabor's team proceeded with the tests. By the way, DNS64, it's 64perf++ is since last IETF available on GitHub, so please go ahead and test it if you'd like to do so. Next slide, please, Anna. So
It's up, by
basically,
the way.
since there are already on the in the open source communities community traffic generators that can be used with this draft, we are working uh, towards an implementation which we call for now 6transperf, and it's supposed to be compliant implementation with this draft. And we don't know exactly, since our team is not, yeah, it's small, and we're all kind of busy. We're not sure when it's going to come up exactly, but we hope by next IETF we're going to have something. So at this point, I have some questions for the working group. So the first question I think is mostly for Al, because you had most of the comments, I think. So were the comments covered well enough?
Yes, Marius. In your most recent version,
Yeah.
they were,
Okay.
and that was the one you published, I think, just before the
Yesterday.
deadline.
Yeah.
Yeah. Oh, yesterday. Right. Okay. So.
I missed one of the comments, so I added the reference, but I forgot to make the modification in the text. And Gabor picked that up, and we made the correction. Also, I think this is a question for the working group generally. So we've been through two working group last calls. We were wondering if it shouldn't be time to go to the ISG review. So.
So let's take this opportunity. Let's take this opportunity, Marius, to ask the working group. Since you've given us a nice summary this morning, are there any further comments on the draft? Okay, seeing none. I think then the only remaining question in my mind was you were thinking about covering this packet coloring topic. And I'm wondering if you wanted to include that in the current draft, or whether you're willing to just sort of stop now that that you've reached the state of pseudo consensus here and move the draft forward.
Yeah, since it's almost consensus, we thought about it, and maybe we're going to discuss that topic in a future draft. It might bring up too much controversy, and that means the draft will have to go through another working group like last call, or I don't know, it's going to delay the publication. So we're very close to finishing. That's why we decided not to include that in the draft anymore.
Yeah, I was kind of surprised that you were even thinking about it. So let's then watch the mailing list for a call of consensus on this potentially, and there's no further comments, I guess, here in the room. So well, thank you for your efforts, Marius. This has been a very interesting experience taking this draft through. A new person to the IETF, such as yourself, joining us in the Honolulu meeting, which was an optimum time to do that.
Yeah, it was the first great first meeting. Yeah, IETF 91.
Yeah, you get the award for choosing the best first meeting. I think that's absolute. All right, very good. So so no comments on this, and yeah. Yeah.
Okay, then thank you very much, Al, and everyone. And yeah, I'll be commenting here if I have anything to say. Thank you.
Right, and then so very good. Thank you. All right. So let's see. Okay, I think the next one I have to get out of email here, Sarah. Where is Sarah? Here we go. Oh, we got them both now. All right. So these slides did you upload these slides?
You told me to email them to you.
Okay. And, right.
I think these are short and sweet.
We'll upload these after the meeting.
Yes.
I apologize to anyone participating remotely, but the upload will take place shortly.
If there were awards for the shortest presentation, I'm pretty sure I'm going to win it. This is the SDN controller draft. I'm presenting, I know you're used to seeing Bhuvan in here. I think I've been presenting the last couple of IETFs anyhow. He's out of India. It's a little hard to get here for him. So next slide, please. So it's a pretty sweet spot to be in. Since last IETF, we went through a second working group last call. We received comments from Al. Thank you, Al. They were really, really thoughtful comments. We've accepted, I think, every one of them and updated the draft to reflect those comments and that feedback from you. Next slide, please. So pending feedback or additional comments coming in today, I think we're at the point of saying, Al, thank you, we're ready. Let's move this through.
Right. So I'm just checking the remote participants. One of the things I did was to circulate these drafts among the Open Platform for NFV Controller Performance project. And we haven't gotten their feedback yet, although Bhuvan has been participating in that work. And I think, in truth, some of the feedback has already been passed along. So I don't think we can. Don't think we have to worry about waiting very long to get this. But there is going to be some time in preparation of the the document Shepherd's sheet and so forth. So if something comes in the meantime, we'll do that. But I think that the working group seems to be fairly satisfied with these, and I'm happy to see that in particular this idea of lossless asynchronous message handling is included. A lot of the controller benchmarking tools were about looking at the maximum rate, which is the equivalent of our maximum forwarding throughput, and that has necessarily no look at loss. Well, the bottom line is the loss of packet ins in the open flow parlance. The loss of packet ins means that flows are sitting out there waiting to be forwarded and waiting to have table entries that reflect them. And so if you're losing lots of packet ins, it means that lots of flows aren't being served well at the capacity, this maximum capacity you're talking about. So that's the big change in this draft, thanks to the comments that Sarah mentioned and some interaction with this OPNFV controller performance group. And there's a number of tools that make this measurement now, at least that measure the loss. Bhuvan has one, and his company, and there's some others around as well, like the Latte open source tool. So I mentioned those that for folks that may be doing some experimentation here and have some interest. Jay. Is that working? I don't know. Pound on it. Oh, now it's going.
So yeah, first of all, yeah, nicely written drafts, very useful work item. One question, this is for Sarah. If it's out of scope, just let me know. There is a section that talks about control session capacity. I think that section focuses on scalability aspects of the number of protocol adjacencies and stuff like that. The question I have is, do we need to include parameters such as IGP database? We're talking about sessions, which is essential, but when you look at a controller, maybe this controller is learning IGP topology information from a protocol such as BGP-LS. Do we need to even be, thinking about the database itself, the size of it, and start talking about it? If it's out of scope, it's out of scope. I just want to know.
So it's an interesting question. I'll be honest, we haven't actually internally talked about that at all. So I'm not entirely sure how I feel about that. So I think what I'd like to do is take the question back. I'll circle that through with the other authors, and we'll follow up on the list. How about that? Yeah.
And in fact, Jay, if you could pose your question on the list, that would be great.
Absolutely.
I am on the
I'm on the notes section as well. I'll put this on the Jabberal as well as there is this tool to capture minutes. I'm going to put it on there as well.
Okay, that's fantastic. Thank you. Yeah, and I think, I mean, there's already a section of about discovering the network map, and this is very akin to that. So I think that's I would guess that this is the kind of thing that might be in scope for some. I mean, it's certainly something some controllers might do, but let's sort that out. Yeah, good point. Thank you, Jeff. Any other comments or questions on the SDN controller draft? All right. Well, let's leave that as we need to see how that discussion goes, and then we'll take this up. Sorry, we'll take this up as we can, and that takes a little pressure off of me writing the shepherd's form. I can get it started, but I don't have to finish it. All right, excellent. Good, thank you, Sarah, for that presentation, and we'll get those slides up there shortly. All right, so then the next topic is going to be presented by me. This is the virtual switch benchmarking draft from BMWG. From OPNFE, I'm sorry. There's lots of acronyms in play here, and you'll see that that this is about to expire. But if there's any additional review that we want to do on this, basically the working group last call was held, as I said, during the last meeting, and Sarah, it has to be the consensus caller chairman here, because I have I've actually been working on this project almost since its inception with Miriam Tahan, who's presented this to us several times, and Billy O'Mahony, who they were key people from Intel on this at the beginning. And this is actually an OPNFE. This is actually a draft we're kind of proud of. It shows the possibility for interaction between the two areas of work, the standardization community here in IETF and the open source community in the Linux Foundation project on OPNFE. So this is a summary of that work, and it's one that benchmarks virtual switches using very heavily references to our drafts here or RFCs really here in the IETF. So it's got many detailed procedures that we have accessed by reference to the open source documentation. So that's the way this draft has worked, and it's basically a summary of the situation and a list of the tests that we created, and the summary of the specifications as well. And of course, we have this 3x3 matrix. Using this matrix, we are able to kind of characterize the coverage of our benchmarking work. And this is something we introduced just a few years ago in our work here. It's described in some detail in the NFV and infrastructure considerations draft that we've just got IESG approval on. So I encourage you to go and take a look at that one. But you can see that in this draft as well. So it covers all these different functions: speed of activation for table updates and so forth, the accuracies, the reliability, scale, and so forth. So that's the different categories, and we have tests that cover all of these. So that's the quick summary. And as I said, we completed the last call, and the last call was completed with no comments, so it was a good outcome. And so now I guess I'll turn it over to Sarah, but it's kind of like a watch the mail.
Yeah, I think Al just stole the thunder there. How many folks have read this draft? Technically. All right, I see six hands, 5.5, 6. All right. Were there any questions in the room? Come up to the mic, please. I get to boss you around today. This is fantastic.
I believe one of Ramki Krishnan. So I believe one of the questions we were discussing earlier in this draft was how do you benchmark access control? For example, you add an ACL and V-switch. How is that going to impact performance? I saw some sections, some reference back, but of course I didn't look at the draft the latest. I was browsing through it, I couldn't find any references. Perhaps it's worth mentioning for completion, right?
Yeah. So I think we've got that covered in a at least a general way in this draft, Ramki. And further, since we started this work, we've actually done some work in ETSI NFV on path performance. And the example, I'm the rapporteur for that particular document. It's test 004. And when I was pressed hard to come up with a, sort of an example of this path testing, the one I came up with is the decomposition of a router into 3 VNFs, an ingress and egress access control list, and a routing function in the middle. So there's actually a really nice appendix that shows how that would be done. So I don't want to add a bunch of stuff here that would overlap with that. I think it's something that our collective industry has covered. So let's shall we leave it there?
Or as long as we capture the fact, so for example, the reason and bring this up is because of processor architecture.
Could you get closer to the mic?
Oh, sorry. Because of the reason how processor architectures are in terms of caching, the levels of caching and how software systems work. What happens is as you increase the number of access control lists, the performance can dramatically exponentially differ.
Of course, that's been true in the physical world as well. No surprise.
Physical, I mean, in the sense you have a table scale, you determine that hey, this is the scale, right? And then as long as it's in the scale, we have a TCAM, then you have kind of a deterministic performance. But in here, what happens is, say between 16 and 64 rules, you will see a performance difference depending on what algorithms are being used. So, in the sense, it's kind of changing dramatically as you increase it, dramatically getting worse as you change the scalability of the table.
So you'd have, and this would be a particular case where you'd want to be. I mean, the one we decomposed in the ETSI NFV test 004 document is kind of a router's ACL function. So you're assuming here that you'd want to be doing the same thing on a switch.
Correct, because basically that's the front end, VMs, right? So you would want some kind of firewalling, capability.
Yeah. I think that's definitely covered in our list. So at the high level, which is what this document is supposed to cover. So thank you. And you've given, and it was a great leading question. You've given me a chance to talk about some other work that's going on in the industry. So I do appreciate it. I'm glad that our thoughts dovetailed on that. Thank you. All right, back to you.
All right, so I think the next, you're going to ask me the next steps are we want to go through calling consensus, which I need to do, and draft right up, and we'll send it through to publication. So barring any further questions in the room or on the list, be on the lookout on the mailing list for that update.
Great, thank you very much.
Thanks, Al.
Folks coming in, please find the blue sheet. And so who's got the blue sheet? Please put up your hand. Yes. So thank you, Diego. All right. So that was fairly simple. Let's back up here. Appreciate everyone's support with this. And so do my co-authors at OPNFB. All right. So let's see, here we are. So the next person we're going to hear from is Samuel Comer, who's new to the group. Welcome, Samuel. So now we have special rules for presenters who are in the room with us. So everyone listen, but Samuel in particular. You'll note, oh, because we've got this pink box up here. You must stand in the box. You can't step out of the box, no. And but you're welcome to take the mic out of the stand if you find that more convenient. And let's make sure it's working. Just give it a little tap. You may need to turn it on if you can figure out how to do that. There we go. There we go. All right, give me a moment and I'll get your slides up, and then we'll be ready to rock and roll here. In fact, I'm going to close this now since we don't need to get slides anymore, I hope. All right. It's this one, I think. No, not that one. It's well enforced, Jacob. Well enforced. All right. I think we're ready to go here for a change. Here we go. All right.
Thank you. Samuel, I'm Samuel, and
Samuel, you may need to pull the mic out of there and hold it close to your face all the time.
Yeah.
Right? That's good.
oh, thank you. And like Al mentioned, this is my first time here, so please be gentle. No. So this particular draft, even though it's mentioned as 00, this is the second revision of it. We presented, actually Jacob presented it maybe a year back or something. And so we'll go.
Next slide. Yeah,
Yes.
Here we go.
So this is basically focused on the NVP, like network virtualization platforms, and not NFV. And I think there was a discussion around, okay, what's the difference between these two, right? And I've actually included that in the draft, but going through some of the reasons why we kind of recommend, why we feel we need another way to test this, is because we're looking at infra, like when you look at the virtual infrastructure, right? Whether it is a switch or a router, especially in the NVP platforms or network virtualization platforms, there's a difference between the physical switches and the logical switches. And we'll look at what the differences are. And again, like I said, this is not focused on NFV type of models at all. Just to make one statement there, to me, NFV is where you're taking a function like a switch function or a router function, and you're basically emulating whatever a switch or a router does, right? Versus what we do, with the NVPs, it's a little different, where the NVP platform can actually stay close to the application and do things a little differently. And we'll look at why, how it is different. And some of the considerations we're looking at is because of where the NVP is placed, I think it makes more sense to actually look at it from an application layer when you're benchmarking it, versus what we are used to in the physical switch switching world. It's a little different there. And then again, the DUT model versus CERT model, right? We kind of look at the devices as a black box, but in this case, every single thing that goes inside that box actually makes a difference to what your performance looks like. So there's a need to kind of document what's in the box, and often, like, some of this testing is also inside the same box where you actually have the logical switch and things like that, right? So it makes sense to have a list of what is going on with the box in terms of like things like TSO, RSS, and stuff like that, and also any other hardware related offloads that are available on the box. And microservices, I've seen a couple of drafts, right? This model has been picking up quite fast. There's almost no organization which has not moved on to a microservices type of model, right? So some of the testing, basically that is focused on that, and again, bringing it back to an application layer versus a pure network-focused device level testing. And finally, documenting all this, because unlike a black box where you run certain tests and then you expect the same thing to happen in any other box as long as you have the model number, right? Here, it's just not the model number. There's so many things within the box that actually influence. So it's a list of things that that you probably have to take. It's almost like a, what do you call, bill of materials or whatever, right? And all those things together, they have an influence on the performance of that box. So again, documenting what those things are, like what's actually used to build this server. And intra and interhost, like sometimes it's very interesting, like because there are no restrictions when you're within the box, when you're sending data from, let's say, one virtual machine to another virtual machine, and everything is within the same box. Sometimes there are no limits in terms of, like, the bandwidth that you can expect, and and so there are folks who try to push everything onto the same box. So what kind of benefits do you see there versus interhost? I've kind of addressed this all in the draft. By the way, how many of you read this? I've only updated this like a couple of weeks back or so, so I don't know if anyone got a chance to take a look at it. Oh, cool. Thank
Good.
you.
Good. Thank you
Thank you.
yes, one is a co-author, of course.
Okay. Okay. I've made a few changes. Actually, if we go, that's a
Well,
good one. So,
Actually,
thank
as a participant, I have a question at this point, Samuel, if you'll forgive my interruption. On the scope section here, you say that this is for hypervisor-based network virtualization platforms only and not NFV. What do you mean by not NFV? And I'll say more. In my world of NFV, hypervisors and container systems are the general solution for the virtualization layer.
Mhm.
This is, in fact, this is actually restricting itself to a part of the virtualization infrastructure, hypervisors only. But then I have to say, probably the word hypervisor appears in the considerations draft that that we just got approved by the IESG. So I think scope-wise, we need to make a distinction between this draft's emphasis and the other considerations draft that we've been working on for roughly 3 years and just got approved.
Okay.
This is my point. I think there's ways to do that. There certainly are ways to do that. I mean, your emphasis here is on the data center.
Mhm.
And I also see a lot of emphasis on overlay protocols.
Exactly. Yeah.
So maybe a tighter scope will be what is a unique contribution here in the considerations space. But this other draft, which I hope you've read, tries to cover a lot of this. It certainly tries to cover the server hardware cataloging and the documentation and so forth. I mean, it introduces the 3x3 matrix and other things like this that I don't see you nodding, so you may not be aware of them.
No, I have actually taken a look at that, and I think there is a difference between what, in my understanding, the NFV is almost like a switch, emulation of a switch, where you're still looking at packet rates and packets by second, whatever, right, PPS and things like that. And the characteristics of the servers do have an influence in terms of, like, you have a faster CPU, you end up having better performance, right?
Mm-hmm, mm-hmm.
This is not necessarily true with what I'm working on here, because there may be other characteristics within the server that could actually influence your traffic way more than the CPU itself. And I think there needs to be a difference, and what do you call, I think that is something that I would start probably taking a look at,
add on to it
tightening
as
the
well.
scope.
Jacob Rapp. So yeah, I mean, I think what Samuel said is correct too, but I think it's just really simply, we're looking at an application versus a function, right? I know some of the NFV work could look like an application too, but I think ultimately, I think you're right that we need to narrow in the scope a little bit to find that kind of sweet spot where we're looking at just the end host as the end piece is an application. It's not a network function. So you're not doing things with the hypervisor to like make sure we optimize on packet rate and optimize on different things to make sure that like a 64-byte packet rate will do really well through the hypervisor versus an application. There's a lot of different nuances there when we look at that.
Okay, all right.
general.
So that's, I think that's I think that's the beginning of a good discussion where we can carve out the unique contribution of this draft.
Yeah.
So let's continue to work that. Looks like we have yet another comment from, go ahead.
Diego Lopez, Telefónica. Well, I can understand the differentiation between platform and the functions, and this is something that I can understand. And well, although I think that we have to characterize this, and I tend to agree with Al that we need further discussion in delimiting the where the platform ends and when the function starts and when the services. What I'm a little bit curious is about why do you consider the microservice architecture as part of, as something to be considered when benchmarking? I mean, if we are benchmarking, you are measuring something, some characteristics, and well, that could happen that something like microservices will benchmark much higher than any other approach. But if what you do is that you are somehow favoring that architecture because you're applying testing in a certain point, somehow you are, fooling your own measurements, right? It's my concern here.
Okay. So I think one comment on the microservices side, right? The reason why I've included this here is it's another, again, looking at it from the application side. We are going from a typical web app DB type of tiers into a completely different model where even though each of the microservices is performing a different function, like one of those could be a DB, one of those could be an app. From an application perspective, they all probably are working on a web interface.
Exactly, and that's why you should not care whether there are microservices or there are virtual machines or there are whatever else. That's my point.
Right. So, but like when you look at that model, right, it is actually bringing in a scale factor instead of, because now you have like within that same box, not 3 different applications working on 3 different ports, but could be like 10 or I don't know how many, right? Like, actually, I think I've come across a number of 100 or something, right? All of them doing the same web function, working on the same ports, and basically bringing a scale-related issue.
Yeah. Fine. So then that would imply that if you have a microservice environment and you are addressing a particular benchmark, you will outperform anything else. I mean, I'm not arguing against that. I'm not arguing that microservices can bring different level of scaling or whatever. But the arguing is whether for benchmarking, you need to consider that you're using microservices. You see my point?
Okay.
Is something that is, I mean, you're testing between 2 points.
Mm-hmm.
Well, whatever happens inside the points should be transparent. I mean, some architecture would be much better, other would perform much worse, but it's something that should be transparent unless what you want is to build a microservice benchmarking framework. That is something that is different.
Okay. Let me think about that.
So I'm going to butt in first. So I think we're flogging a dead horse, guys. Sarah Banks, speaking as a participant, I think once we delineate exactly what the scope is, either we will have to have this fight or we won't. And I'm really hoping that we either figure that out or we actually have another draft and somebody comes in and actually benchmarks microservices. So that would be nice. But until we know what the scope is, it's
fine. I'll keep my strength and my forces for that.
I think just to add to Diego's Ramki Krishnan again. So Diego's comments. I think we need to be really specific about microservices, and one of the angles I see is more of the parallel processing angle, not just the scale angle, because the scale angle is standard. Independent of microservices, somebody could argue for scale, but you're calling out and saying, hey, there is an entity which is doing parallel processing, dispatching these microservices at scale, and then gathering responses. Then I see some more value. Okay. On that.
Okay. All right. Good. Thanks for those comments. And let's let you get to slide 3. Okay.
So a couple of things I've added in the draft from the previous one that was like a year back, right? I've just added this 2 weeks back. One is description in terms of a section in terms of describing what is different with this NVP platforms. From when you look at it from an NFV perspective, right? What is different here? And second thing is, I believe there was some questions around repeatability of these tests. So I've added one more section on the repeatability of the tests too. If you haven't read that, please do take a look. Especially the new one. Now it is accessible too. So,
Thank you. All right, on to the next.
all right. So I've been talking about like there are differences between hardware switches and even NFVs, right? To what we're looking at here when we go into a logical switch or a router inside a hypervisor. Some of these are pretty simple, right? Like you're looking at like maybe a 24, 48 ports of 10 gig, 40 gig, whatever you have. Versus what we have on the server, it's a distributed system with maybe 2 ports at 40 gig is a luxury. In most cases, it may be like 2 ports of 10 gig and whatever, right? And you have the entire x86 platform that's actually driving this. And those are like easy ones, but the other ones are like, are they limited by ASIC versus limited by CPUs and stuff? Working closer, the point that to me makes the most importance is that this platform actually works closer to the application layer segments. If you look at the physical switches based on the MTU settings and stuff like that, you're basically looking at maybe a 1500 byte packets versus what we're looking at within the hypervisor for the NVPs is something that's closer to the application layer, which basically means something that's actually able to take advantage of the TCP level offloads, TCP stack, and be able to basically leverage those offloads, right? And so these platforms, like they end up looking at not packets, but maybe 32 to 64K segments, which is quite different, right? Finally, of course, the nickel offloads and things like that, they make a huge difference. For example, when traffic is coming in, there are capabilities within the NIC like LRO, which actually help make a larger segment. Where basically you only have one touch point for a huge payload, right? Again, doesn't happen in hardware, what do you call hardware world, or even within the NFVs, right? So those are some of the things, SSL offloads and things like that. Those are some of the things that actually differentiate the NVP from the physical hardware. And this is the reason why, especially the fact that it works closer to the application layer is the reason why we kind of feel that there needs to be a different benchmarking approach for these platforms. Comments, Ram? Yeah, I saw you smiling the moment I started. So,
so a couple of points here. Number one is
Get closer to the mic, Ron.
sorry.
Really.
So are you saying this focuses only on x86 platforms right now? Or you're not looking at ARM-based any ARM-based servers at all? Is it considered out of scope or?
yeah, great question, right? Any server-based, hypervisor-based system, right? x86 is something that I just mentioned. Maybe I shouldn't mention it. Yeah, but yeah, any such platforms,
It's worth
right?
generalizing. I would definitely say, and then say, hey, as a scope factor, we're not doing it. But the way, in fact, that's going to be one of the points I'm raising up in the other presentation that ARM servers are up there now. It's something to keep in mind, right? And these functions could be running at any location, could be for edge computing or anywhere, everywhere, right? Not limited to a classic data center. That's number one. Number two, also the point I want to raise about offloads, especially it's worth thinking about the micro burst we can cause. They of course give a bulk performance benefit, but the way they work is essentially the batch packets and then dispatch them to CPU versus one at a time. So that would dramatically change how we need to benchmark and how applications will take.
Are you speaking about the LRO aspects of the NIC?
LRO,
Exactly.
LRO, yeah. So basically, they will cause microbursts to the application. So basically, you will gather a burst of packets and then assemble and send it one shot. Right? So that you have to benchmark that aspect.
Okay, maybe we're kind of like looking at two different things, right? So one is the LRO aspect where you have like multiple packets coming in, and the NIC card is actually trying to make a larger packet and send it up the stack. So the rest of the system actually has only one touch point. Like I mean, to push a larger payload instead of doing 40 different touch points for smaller payloads, so you do one touch point and send the whole payload up. Versus what you are probably talking about is like when you have all these multiple packets going through the entire system. Now that I think it's more likely to hit NFV style of what you call appliance. But let me think about whether like what the implication of microbus would be in a NVP style platform. Okay, okay, thank you.
Yeah, same the LRO thought, and also the comparison of if there is no LRO, we need to compare both scenarios, offload versus non-offload.
Oh, okay.
And also
Yes.
the microbus. So basically, we need to lay out all this because not all people use, adapters LRO, right?
Absolutely.
Not a standard feature.
Absolutely. And that's one of the reasons why we call out like that needs to be documented, because you would see a huge difference between one versus the other. Absolutely. I
And
agree.
also, even on the SS level, I would say we need to be cognizant of other accelerated technology, Intel Q classes, right? And call out whether they'll do the job for you or not, whether they can be usable for acceleration, worth thinking about those too. Not
Excellent.
limit
Okay.
ourselves to just the instruction-based, offloads.
Okay. Okay. Yay. Okay.
Yeah, if you look at our microservices, like a lot of different kinds of options,
Okay. Okay. Thanks. Any other comments, thoughts?
Next slide.
All right. I put in the slide just to give a rough idea of like why this is important, what is important, and how much of a difference does do these things make, right? Going back to Ranki's point of TSO, LRO, RSS, when you have that available versus when you don't have that available, right? So the first case where I basically said none, we're looking at about 3 gig performance on a 2.8 gigahertz processor, basically, right? Processor-based system. We are looking at about 3 gig there. But at the moment I introduce TSO and LRO into that system with a NIC card that actually enables it, I'm basically looking at 4 times the performance, and it could be even more, right? So, and including the RSS is basically 4 queues, right? By the way, I keep using these terms, TSO, LRO, and RSS. You're all familiar with this, right? Because we'll look at those terms anyway in the next couple of slides. But basically,
Do you have a reference form here? We'll just flip forward to, oh, this is where you explain it, okay, in the future slides here.
yes.
All right, so let's,
So maybe we'll
so
take a look at that and then.
we're
Okay.
here on the results.
Okay.
What you're basically doing is tipping your hand, saying what we're going to describe works better.
Right. Right. So again, RSS, it basically gives you multiple queues, multiple processors working on the same data. And what you see is like literally again, based on the number of queues, I've taken a 4 as a number here. You basically go up to like 40, this was closer to 48 or something, right? We've seen data that goes up to within the same host that goes up to 100 plus gig. Some of the tests done like at Intel and stuff, right? So 100 plus gig, just using this TSO, RO, and RSS stuff. So there's a huge difference. And what do you get when you get a server, right? What are you actually getting, right? So I think it becomes essential to actually look at these application level test benchmarks and the server systems that are allowing you to get to that performance level. So you have a realistic expectation of what that server can do. And to get there, we have to get into the nitty-gritty details of what that server actually has, and it doesn't remain what you call a complete black box anymore. So, okay. One other thing to note here, again, there's no real rigid port capacities in your virtual infrastructure. It's not like here you go, here's a 10 gig logical port, right? Whatever is the capacity of that server, it could go to 15 gig or whatever.
Okay. So now this is an animation where we're going to interact quite a bit.
Yeah, I will. I would just build it out. Okay, so between just an explanation of what TSO does, right? So TSO basically is an optimization that's been there for like a decade or more, and what it does is instead of having the Linux kernel or the CPUs actually do the act of chopping your payload into sizes that are consumable by your network devices, that is the physical switch. What TSO does is it offloads that task from your system and basically gives it down to the NIC card. So the NIC card should have the capability to be able to look at a packet and then divide it to MTU-sized packets, basically, segment to MTU-sized packets. So I would just build it up. Yeah, so you're passing this, like, let's say a VM is passing a payload down to your NIC card.
Next one?
Yes. And the NIC card actually, it takes that single large segment, it could be about 64K, and it actually divides it into multiple smaller segments. The idea behind this whole thing is you are saving your CPU cycles. Instead of wasting CPU cycles, you're actually allowing the NIC card to do it. And then, but if you were to do it with the CPU, you can still get the job done, but you're basically burning your CPU cycles just getting this, what you call packets, right? And also, when you use the CPU to do it, what happens is that VM and within that hypervisor, what happens is every single switch, the logical switches, the logical routers, the virtual infra that's inside that hypervisor, they have to actually look at multiple packets versus a single large segment. So just to boil it down, like if you look at 1500 MTU versus 64K, this is one operation versus 40 operations, and 40 operations into whatever are the CPU cycles. So there's a huge difference between these two, and NVP, because it is closer to the application layer, it allows you to start looking at packets at this layer. Okay. Thought.
Ramki, when you come to the microphone, there was feedback from Meet Echo that you were, they couldn't make you out. So make friends with that microphone, please.
It was like the first two words we could hear perfectly, and then you went back to normal Ramki mode.
So Ramki Krishnan again. So I think while we're capturing TSO, it's also important to think about low latency applications, and the batching may actually be counterproductive for them because you're waiting for the batch to be basically complete before dispatching the full packet. So some of the considerations to think about.
That's true. It's actually more applicable to the LRO side, which is the next slide. In a TSO case, what happens is if the application gives you larger data, then TSO is implemented. If the application gives you smaller data, smaller amount of data, TSO doesn't play at all. It would just pass that information down. Okay. Yeah. But on the LRO side, yeah, that's a really valid question. Actually, the next slide. In the LRO case, actually, I would build this out. I'm sorry, I should have removed the end.
Oh, sorry. Okay, now we're good.
Thank you. So in the LRO case, the latency becomes a concern here because once you enable LRO, it's basically waiting for a certain period of time to get all the packets and then make one larger segment, and that would have implications on the latency. So this is kind of like a knob. Are you aiming for throughput for your applications, or are you aiming for latency, right? Based on that, exactly.
So I do want to point out, hey, having that conversation or just a paragraph on that in your draft, I think is helpful as customers look to vendors and say, hey, how does this or does it not affect what I want to do? Having that conversation there, I think shortcuts a lot of that because you already know it. Proving that out and showing it in the draft, I think is helpful.
Okay. Okay.
Thank you.
Yes, I like that. So LRO, just one couple more points. LRO is just the opposite of what TSO does. TSO is for traffic that is being sent out. LRO is for traffic that is coming in. TSO is very deterministic. LRO is like, it depends on like, when the packets arrive, what time, how long they took and stuff like that, right? It's not that deterministic, but it still has a large influence on what your performance looks like, both from like, do you spoil latency versus not, and throughput, like higher throughputs and things like that. And the last part is are you using like a single CPU or are you using multiple CPUs to process your traffic that's coming in? And RSS is basically a feature that actually helps look at that and determine how many queues. Here I put like N. Most of the RSS queues are about like 4, in most cases 4 to 8. You can almost look at like, if a card, a NIC card has RSS enabled, you could go from like, you could increase your throughput performance by 400 times, as we've seen in the results before. Any thoughts? Again, all of this, like the way I've called out in the draft is these are things that basically influence your performance. So you need to document, did you enable it or did you not, right? Because there could be a huge difference between what's enabled and what's not enabled on the same system with the same, what do you call, say exact same parts.
Ramki Krishnan again. So one of the things that occurs to me is, are we going to look at a fully specific set of features or the exhaustive list? What's your thought process? Or are you going to systematically get there? Because there are several other features, like for example, flow director from Intel, I can see like, gazillion features. So what's the target objective? And there is a big list, and essentially these all come in the category of hardware acceleration, in fact, looking at how to model them generically, right? So to me, in fact, as we progress, a generic approach would help and say, hey, but we are specifically focusing on these, at this point. That's my thought process.
So I've actually given a pretty exhaustive list in the draft, but again, we are taking a generic approach because the main idea is to document what was available and what was used. And there may be things that would come like receive RX or whatever, right? There are a few things that are already here, right? There may be things in future too. Our focus is not to call every single thing out in the draft. I don't think that could ever be finished, but take a generic approach like you were mentioning. Main focus is to document it. This is the feature, and this was enabled, and what the difference is from the performance perspective.
Okay. But I think, generic approach worth also referring to the exhaustive list. We are doing a lot of work in that area. You're worth referring to those. So
okay. Awesome.
Ramki, who's we?
So the V is basically from NFERG and work in the past happening in open source. That's what the V is. So also there is references from OpenStack and Kubernetes and what you can bring from NFERG combination.
So with my chair hat on, maybe the NFERG chairs who are both here might consider having Samuel come in next meeting and cross-pollinate this draft as a presentation on the other side.
Sure.
Thank you.
All right. Next slide, please. Okay. So we've looked at just 3 of those, like as Ramki was mentioning, like this multiple different things that actually help with this, what you call, they influence the performance and MVP platforms. And coming back to like what the tests itself, the benchmarking methodology itself, right? Because the MVP platform is close to the application layer, our suggestion, the draft basically, we're suggesting that we stay close to the application level requirements versus like if you look at what's applicable to today, right? Like if you look at it, HTML pages like what's served and things like that, average page size is over 2 meg today. And average HTML content, I mean, of course, it varies between whether you're serving an image or you're serving text, but average, it's about like 56K something, which is way over the MTUs that we look at the physical layer, right? And because you're looking at this app is actually sending a 56K, what do you call, stream down, let's say 56K file down. The MVP platforms look at that 56K. They don't actually look at 1500 byte packets. And that makes a huge difference. And even when you look at the, what do you call, response times and latency, when you look at it from the application layer, it's quite different from what you see on a physical switch, for example, right? So staying closer to the application layer, and most of the applications also come with their own benchmarks. For example, Memcached has something like MemSlab, Apache has something like AB. Our suggestion is to stay, use those benchmarks and which are closer to the application level, and then document them too. You could say I've got 10 gig throughput out of the system, but it depends on what benchmark you've used to. Two different benchmarks focused on two different things could give completely different results. So documenting what was used.
Hey, Jacob Rapp, I just wanted to add a comment. I know last time we presented a couple of IETFs ago, this was some discussion around, we're not actually dictating here's the test you should use, but you should be benchmarking at an application layer as well. Like I think the next draft is presenting, we'll talk about 64 bytes to 1500 bytes. That's just a discussion we had. If you just do that, you may not take advantage of an offload, or you may do something completely different. So you still need to do that too, but if you miss the application level benchmark where you're sending large chunks, you're going to miss a whole big portion of what the system can do.
So you have to build enough of the application into the benchmarking system to recreate that, I guess. And so there's a challenge for the test equipment manufacturers here too, I suppose.
Ramki Krishnan again. So I was thinking deeply more about the specific term NFV, what or not, right? So I would say the best way to capture it is like you are not looking at middle boxes. I mean, non-terminating middle boxes, because in NFV we capture virtual CDN, and basically what you're seeing is totally applicable there, right? So if you, instead of putting a broad term NFV, you go down more specific to non-terminating middle boxes such as NAT, right? Give an example, then that'll be perfectly covered. Right? Then we're talking about applications, and they could mean NFV style applications like virtual CDN, but not NFV. So it's really getting more specific than that.
Okay.
All right, was that it?
Okay, next slide. This is basically just calling out some of the benchmarks, benchmarking systems that you have available today, like the ones that I was already mentioning, right? Like AB benchmark or IPERF. Avalanche, I basically called it out here because if you look at most of the traditional benchmarking systems like Ixia or Spirent, right? Especially the ones that focus on like 64 byte to 1500 byte kind of tools, they don't really they don't really give you the actual performance that you can expect in a NVP, network virtualization platforms, because you could be testing 64 to 1500, but now the application itself may be sending, like, let's say, way over that, and the NVP platform is actually working with those segments, not 1500 bytes. So having Avalanche here is basically a TCP based test tool. It could help a little because it's kind of designed a little differently. So I kind of included it there, but the main point is to go back to the benchmarks that were designed for that application.
Ramki Krishnan again, a quick question. So are you covering storage traffic also? Because while you're talking NVP, storage, you do allow storage traffic through the virtualization vSwitch, right? Or you consider a separate path? How is that considered?
Um, I would say like this is mostly for the overlay networks, right? But any I mean, you could actually use an overlay or whatever, right? That's a possibility. As long as it is an overlay-based traffic, I think it may be applicable. But I have to think about that.
Because the reason I'm bringing it up is the moment you say application level benchmarking, then you really need to do end-to-end, right? You can't just say I'm covering this part of it. So you have to describe, there is always a storage part with the application, typically, right? So that's the reason I'm bringing it up. The moment you're actually looking at the application benchmark itself.
That's an interesting comment. So for some of the apps, I think it does, I mean, storage does actually play a role there, right? And let me actually think about that. I think the way we addressed it is every single component that's part of that test needs to be documented. And in that sense, the storage is also part of this, what do you call, test, right? So in that sense, it is addressed. I don't know if you were kind of hinting at like a bit more on that, or
So my point is, the moment you're saying application, that also needs to be considered, depending on the application. In some applications, it may not matter, but we need to take into account so what that means, right? I mean, we have to get more deeper into that part, the storage part.
Right. So we've got to hustle this along. I'm going to make a quick comment here that we can follow up on later. And that is iPerf, I would suppose, you're going to use a TCP-based thing there. There's also a role that TCP flow control plays in this benchmarking, and that can make the results a little less repeatable or more difficult to repeat when you're experiencing packet loss or variable delay. So I would encourage you to take a look at the traffic management RFC that we have previously approved here. And that's where we tried to get a handle on some of these TCP effects for stateful traffic. So I think that's a general feedback here that memory is an interaction. The transport protocols that are trying to do reliable delivery, those are a point of interaction. There's messiness that you're going to have to grapple with your sleeves rolled up. This is the general feedback. Oh, so that was it. Okay.
So,
awesome.
Any other comments?
I hope not. You already had a great discussion here. but thanks for your presentation, Samuel.
Thank you.
So who's interested in reading and commenting on this draft on the list? Yeah. So list traffic is important. We've got to get more folks involved here, both in the meetings and on the list. It's very convenient to be able to do this at the mic. Okay, so we're planning on some future exposure with NFVRG as well. That's great. Thank you, Rocky. Yeah, very good. Yeah, nobody can hear him. So, okay, so Ramki's saying we're cross review will be very helpful with NFVRG. Thank you. All right. Thank you, Samuel. All right. So let's get this one off. So the next one up is Mr. Lu Wang. I've got your slides here. Here we go. Okay. So just by a quick way of introduction, we first saw this draft some years ago. Then it was presented by Ru Gong a few times, and so now after a long silence, we're hearing from you again. So welcome back, I think, and
Thank you.
Tell us about your draft. Thank you.
Hello everyone. I'm Lu Huang from China Mobile, and maybe a year ago we submitted the first version of this draft, and um, then we just began to test virtual switch and something like that, and also we use vSwitch in our SDN network, and currently we have some commercial deployment of SDN technology or SDN network. So we really have some different benchmark methodology on this scope. So we update the draft, and later we will describe some difference between this version and the previous version. Next slide. Thank you. Just a quick review on the previous version. This draft introduced a benchmarking methodology for virtual network. It's mainly focused on virtual switch. And we built two traffic model, A and B, because in our point of view, we think maybe generally there are two traffic model. The first one is from the traffic is from a virtual machine inside a host, and the traffic will go out of the host. And another model is traffic is inside the host, just from one virtual machine to another virtual machine, and the traffic go across the vSwitch. The traffic is not out the host. And in the previous version, we described the scenario that the vSwitch and the virtual tester is both of them are based on virtual machine. But currently we found that in most of the cases, usually the virtual switch is installed on host OS instead of a virtual machine. So we upgraded that point in current version. And we describe several benchmarking test case, and include throughput, frame loss rate, CPU consumption, memory consumption, and latency. Next slide.
Actually, can I ask a question?
Okay.
I don't remember. I think it's just mentioned when this draft first came in. So if it has, and I don't quite remember the outcome of it, but if you're going to have the vSwitch as the device under test, I see you have two models there. I'm not entirely sure what I think about those, but why not have a physical tester that connects into your vSwitch as the device under test, and then transits out again to another physical tester? Because then you're isolating everything about the vSwitch, and the only thing on that machine is the vSwitch, and it makes it a really true, clean device under test.
Because I think in the real network, the traffic is from a virtual machine to another virtual machine. The another virtual machine may be inside the same host or in another host. So if we use a physical tester to test vSwitch, the traffic is always from outside into and.
Right, but if the traffic is going through a vSwitch into another host on the same one, I cannot certainly understand your first example there. But if it's going to another host or another VM on another server, then having your egress tester being a physical one, whether it's physical, whether it's on another VM, the point is you still would have kept your vSwitch in the first case completely clean. So I agree with your first, I think I agree with your first case. Okay. But I think another one, having a physical tester to a vSwitch to another physical tester, or a virtual tester on another machine would be a valid case you might want to consider.
You mean the module A is makes sense, but the
Well, actually,
Right.
this is a topic that Brooks Hicksman commented on the list, and it's effectively an echo of Scott Bradner's comments every time this draft has come up. There's a dependency between both the receiver in the Model A case here. There's a dependency between the virtual tester that's within the server, whether it's both sides in Model B or just one side in Model A, and the device under test. And so, if I can jump ahead, Lou, you're proposing that the virtual tester needs to be calibrated to make sure that the performance won't badly affect the result. And I think that's the key thing, that this idea of calibrating a tester which would be in a shared resource space as the device under test, that's a real question of feasibility. And I see that as the major issue with this draft in general. Brooks Hickman also made a similar comment on the list.
yeah, can I?
Please, so please tell us more about this calibration. I think this is the most important thing.
The collaboration is not really a thing to test the tester. I mean, the collaboration means we should make sure the tester itself could generate enough traffic to test the DUT or the virtual switch. So the collaboration means before we test the virtual switch, we must find how we should allocate the CPU resource and the memory resource to the virtual tester to make sure this virtual tester could generate maybe 10G traffic to test the virtual.
So it's less about calibration and more about configuration.
Yeah, find
to ensure
find a
isolation?
suitable configuration for the virtual tester. Yeah.
So, well, so far that's been difficult. It's been difficult to prove that you can isolate anything with shared resources. I mean, certainly there's ISO CPU and task set commands where you can take certain processes and move them to a particular CPU. But then you're still going to be sharing resources like the memory bus, the last level cache, and so forth. So I think, I mean, I really think that what the working group needs most to hear is how this kind of test setup would be feasible in our view of testing, which is a black box view of the device under test. And I'll say that what Sarah was describing earlier is exactly the approach that we took in the OPNFV vSwitch testing, where we separated the tester physically every time. We have other tests that make multiple passes through the vSwitch to looping VMs, but always the tester itself is isolated from the resources in a completely physical way. So that's, I mean, that going back to the original discussions of this draft and the OPNFV draft, the exact point that Sarah raised is the distinction where we can count on the results from one and they are more closely what we've done in the past, and where this is a big divergence from our black box testing.
Okay, but in my own opinion, I think in some scenarios or cases we can use physical tester only, but in some case or some real environment, maybe it's hard to use physical tester only because sometimes we want to test the vSwitch performance in a trial environment. So the traffic is hard to generate from outside of the environment and insert the traffic into the network. So sometimes we have to use a virtual tester to generate the traffic. For example, iPerf is a very good tool for us. For us, sometimes we will use iPerf to generate the test traffic. For example, we will create 10 virtual machines and run iPerf on each of them and generate a bigger traffic to test the vSwitch.
Yeah, I think can I add a comment? This is Jacob Rapp. Yeah, I mean, I think there is definitely a need to have two virtual testers in the same system, even though it creates some interesting behaviors and we have to document that and figure out how that's handled. But I mean, think of a vSwitch and two VMs talking to each other across that vSwitch. You're gonna do mostly in-memory copies. And performance is going to be a lot different than if you took up a virtual tester, two physical virtual testers. So it just has to be some clear way of doing it, but I don't.
Well, so this is something we actually investigated in the context of the OPNFV vSwitch project, but we did it without Model A or Model B. We managed it in other ways. I'm not going to say what we did, but let's put it this way. There's other ways to attack this problem where you don't have the same resource dependency or the same difficulty in characterizing the generator and receiver. So let's let you continue. I think this is a major issue that needs to be discussed further.
Okay, we will. I think we will find a way to make the or find a way how to make the virtual tester more feasible or more precise. Yeah.
This is the challenge, and also to show that it can be completely isolated in a way. But one quick comment, please.
Hi, this is Ron, and I agree with Jacob. And I want to answer Sarah's question about the Model B, because now in some scenarios, the traffic will not go outside of the server because the virtual machines are all inside one server, so they will not go outside. That's the reason why we present the Model B.
So it's sort of this, for me at least, I grapple as a chair and as a participant with the BMWG mantra of black box testing, right, and having reproducible results. So I think probably of the two of us, I might be a little more comfortable with these models up here. I understand your point. I think Jacob's point is spot on. I think we may have to adapt a little to how do you not do that. I was simply questioning, my point to you was, hey, if you're going to say the vSwitch is the device under test, having something that completely leaves the vSwitch as an option. I didn't mean to say the only option, but as an option where you have physical testers on either side negates a lot of the push we're going to get. So that was one point. I think to Al's point, though, making sure that we can clearly delineate that, hey, the results you get from your two models on screen here are specific to the vSwitch and not contaminated or not because resources were used by either the tester on one side, the tester on the other, or both. I think that's going to be an issue that as a working group we're going to see a lot of conversation around, because I agree it's a problem. I have a lot of sympathy for the point you're calling out, because I think every customer asks me, and I'm sure you guys are getting this as well in our day jobs, how does this affect, how does this one not affect the other one? So being able to prove that and test that, and here in your draft clearly delineate that and define that is going to be I think the crux of the issue, the biggest problem we're going to have to solve.
I just want to add something, and I think we have another concern on the physical test, on using physical test only, because the traffic is different from the real traffic running on a real network. I mean.
So I agree. but I also think running iPerf on either side here also is not necessarily the exact same thing as what you're going to see in the real world, right? It's really going to come down to, are we going to have to get to the point of saying, okay, well, we're actually going to have an application running on this side or that side or on both to sort of reproduce what we might see on a real live network. I think you're going to have the issue
it's always different. But yes, I do think we will try to make it as same as possible. Yes.
So we're going to move along, unfortunately.
Okay.
One further point is that CPU consumption and memory consumption, they're kind of reported by the device under test. We have some standardized metrics for those, but those themselves aren't really benchmarks. They're helpful operations information that we want to know alongside the performance, like throughput and latency. But CPU utilization is in itself not a benchmark. So that's an important distinction to make.
Okay.
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 All right.
That's right.
Moving on.
Yeah, we updated this version mainly on 2 points. The first is just now I mentioned we add descriptions about vSwitch running on host OS, and we think this kind of vSwitch is the common use case now. And the second one is we change the test process and the test result format for CPU consumption and memory consumption because it's more useful for our current test. Before we test CPU or memory consumption only under the throughput rate, but now we test these parameters on different rate because sometimes we just need a 50% throughput rate to in the real application environment.
Ramki Krishnan, so in case you're serious about running the tester and actually the function is going to be tested on the same physical server, you need to actually consider using tools like CPU pinning, NUMA, and make sure absolutely that the tester is totally isolated, right?
Yeah, that's really hard to do.
It's not easy.
That's what I was talking about with ISO CPU and test set.
Or you have to really describe and say it's a multi-socket system and completely isolated. You have to really get there.
Yeah.
Not easy.
So let's not go back to that. I think we talked about that for a good long time. It's an issue that needs more discussion on the list. Let's let Lou continue.
Okay, thank you. I just one more further. And actually, we calculate the CPU consumption and the memory consumption indirectly. Yeah, because
indirectly. Okay.
Yeah, there's no explicit way to find the accurate CPU consumption and memory consumption.
Well, for CPU, okay, let's not go into it too deeply, but I encourage you strongly to take a look at the TST008 IETF draft, which has a metric of CPU, basically processor usage and processor utilization. And there we're basically counting on specific interrupt processes to sample the execution context at a particular periodic time.
Okay.
And so there's some inaccuracies in that method of measurement, but at least we've got a standardized way that can be done. It can also be applied in the virtual world, and there's some inaccuracies additional that creep in there, but that's in fact something we're investigating as part of the OPNFV barometer project.
Okay.
So there's lots of people looking at this problem space. You don't have to solve it all yourself there, Lulu.
Okay, thank you.
Hey, Al, can I ask you to take that comment specifically with TST008 to the list? think that's going to help this and a bunch of stuff that seems to be trickling in.
Yeah. So you want a link to that on the list? Yeah, that's fine.
Next slide. And since we received some comments, we plan to amend in the next version. The first one is in the throughput test, revise the description about how to manipulate the traffic when packet loss happens. Instead of increasing vCPU, because increasing vCPU maybe seems not helpful. So we will remove this description instead of to maybe decrease the rate or something like that. And in section 6.5, Echo server using Echo server may be unable to handle a large traffic, and we consider to replace it with a virtual tester, or maybe we can use a physical tester instead. Next slide.
Yeah, I'll just quickly mention that getting the time synchronized on virtual machines is yet another challenge. Time in their world is not very good. All right.
Okay. And we hope to receive more comments or maybe more helpful suggestion on our draft, or anyone wants to join our work. It's very welcome and appreciate. Thank you.
Thank you, Lou. Any questions other than the long list of them that Sarah and I have been desperately trying to capture?
And we can talk a later topic deeply.
Yes, let's do that. Let's leave it there then, Lou. I thank you for your presentation. Thank you for bringing this back and for addressing the comments on the list in particular. I thought Brooks Hicksman's read of this was really quite good, and the more of those issues we can sort of begin to understand, the better we'll all be off. So thank you. All right. So let's see here. So we've got two presentations now from Sudin. Please come on up, Sudin. And while I'm trying to find your slides, they came in early. You're one of the very early slide suppliers, and I thank you for that.
Good morning. So this is already presented in a couple of IETF.
You gotta get it closer to the mic, I think. Yeah. Just get closer. This way.
Is good. I'll be fine. Oh,
that's
fine.
good like that. Yeah.
Okay. So this draft is basically we are defining certain parameters for benchmarking Y1731, because those who been in the providers, they know they have layer 2 services running across their cloud. So they'll be running the performance monitoring, because which is common, running Y1731. So they'll be running these services. So next slide.
So, and I'll just insert there, Sudin, that for those who don't have their ITUT recommendation decoder ring with you, Y1731 is the Ethernet services OANM specification.
So actually, this is Y1731. They defines the protocol stack, but how to be implemented and how the services are rendered is not defined. So that arises a confusion, like how the multiple vendors will be implementing this, and we have to have defined certain parameters to benchmark. So that they'll have we can benchmark this so that we can get a better clarity, and the customers, the end customers, will be getting will be getting better results. So therefore, interoperability won't be a problem. So we are defining certain parameters. We identified certain parameters, and these parameters are used to benchmark this. So Yeah, next slide, please. So the previous comments from IETF 97, that's increasing the soft time. Then the traffic details has to be mentioned. Then high availability, Sarah mentioned that ideal case, it has to be 0. That has to be highlighted. That is in high availability when you do the routing engine failover. It has to be mentioned 0. Ideal case, that is taken care. Can we go to the next slide? Thank you. This is a topology, and the DUT, the DUT, this is like a 3 routers. It's emulating a layer 2 services, which is running in a service provider environment. So you have the DUT where we do the test, and the L2 services is spanning from the DUT to R1, and we are sending layer 2 traffic. The traffic, layer 2 traffic, tagged packet with various frame sizes. So next slide. So these are the basic parameters we are using for benchmarking this particular Y17331 protocol. So first is the measurement of loss, because we are benchmarking all the ITU Y1731 like synthetic loss, delay, and performance loss measurement. So we are measuring this under different traffic rates, line rate, that is 40%, 80% of the line rate, as well as the different, that's and without traffic. So these 3 are compared, and this should not be shown any anomaly. And another is the impairment. Impairment, we drop the PDU data as well as the PDU. If the PDU is dropped, it should not be affected. Then high availability is nothing but a switchover, or we call it as a failover. So, and another is a soak test. Will be running with the traffic for a period of time, like 24 to 48 or to 72 hours. And the scale. So we will be scaling to X. X is a number. This can be, X is defined as, anyone can define that X. So this can be 100 or 200. So that we scale to at that particular number, and it should not affect the performance. So these are the parameters. Can we go to the next slide? So this, as I said earlier, so we send the various line rate, 40%, 80% of the line rate, and we measure the performance, because we send the data, the performance monitoring has to record the actual data. So without we are sending no traffic, this should not show any spikes or any anomalies. So that is, and we are sending at 40 and 80% of the line rate. If the line rate is, say, for example, we are connected at 1G, the line 40% will be 400 Mbps, and 80% will be 800 Mbps. So we are testing that. And the loss during this traffic, the delay measurement should be consistent. It should not show any spikes. And synthetic loss we'll be injecting the automatically, sending the packet through that. So that should not, that should not be getting affected by the data traffic, which is sent from the traffic generator. So impairment is, we are dropping the packet. We are using a impairment tool. So in the physical layer, we will be dropping the PDU as well as the data. Dropping the protocol PDU should not show the counter anomalies or the spikes. It should not show. And if you are dropping the data, the actual loss should be recorded. So that is one. And the delay, it should not be getting affected with the drops of the data packet. And if you are dropping the delay DMM PDU, it should not be affected. So next slide. Yeah.
You got a lot of acronyms there, which I'm going to try to help people with. Loss measurement round trip, synthetic loss measurement, where you're actively generating traffic that's going to be measured for loss. So synthetic loss round trip. Then you've got delay measurement and delay measurement round trip. That's what all of that stuff means. So this is quite a rich set of OA&M, both the add-on counter packets and as well as synthetic packets.
Thanks, sir. Next. So this is a routing engine failover, because this will be generating the statistics. So that will be used for the analytics, or this can be taken to a server and can be analyzed. So while doing the routing engine failover, or it should not be, statistics should not be reset. The statistics should be in sync. So that's the requirement. So otherwise, what we are getting for the customer traffic, what we are measuring it. If you do the failover, the statistics are gone, then we cannot get meter the end customer, what is doing, what is the things which is happening on his service. So the scale is like we are scaling to X, sessions, and we are running traffic, and performance monitoring probes will be running on it. During this should not create any anomalies, and that is the because during the scale, all the counters should show the exact value. There should not be any spike. That's the expectation. So can we go to the next slide? Soak test. Soak is running with full traffic, keeping the test duty for 24 to 48 hours. And after 48 hours, we'll be measuring the CPU usage. So there should not be any memory. There should not be any core which should not be there, and there should not be any memory leak. So that's the expectation from the soak test. Can we go next slide? Yeah. So we have done significant updation in this. So requesting the chair for the next action.
Okay, thank you for your presentation. Please stay here, and we're going to have a few questions. But the first thing I'm going to mention is that at the last meeting, we clearly recognized that this was a proposal for benchmarking an ITUT study group 15 protocol. So as chairman, I initiated a liaison exchange with ITUT study group 15 and also study group 11. We sent the liaison to the mailing list. The working group approved it, and so it then went out. And because the ITUT was in the process of their 4-year evolution, let's say, restructuring, they really didn't get the liaison until January, and to begin to act on it then. In particular, Study Group 15, which is the home and responsible standards development organization for this protocol, has not had a meeting yet this year. So we don't have an official response to our liaison. And if you've read the liaison, I'm sure, there's information that we would like to hear from Study Group 15 before we even begin the topic of taking this up. Okay. So with your patience, we'll wait to hear. Now, fortunately, I've been able to recruit a normal IETF attendee who has also a strong role in Study Group 15. He's here representing himself today. So please, Yuji, we'd like to hear from you.
Thank you. My name is Yuji Tochio, and from Fujitsu, and working as an editor for ITUT G.813, Y.1731. Working for the editor for 8 years or 8 years, or I'm not sure how long, but anyway, and I'm working as the editor for Y.1731. And as Chairs introduced, the next week, ITUT, the question 10, study group 15, we have an interim meeting, and in April, and the Tokyo meeting, and at the end of the June, and we have a plenary meeting, and the first study group 15 meeting. So at this time, maybe the radon should be issued and back to the IETF, so that and IETF has some input from ITUT regarding to the radon back by flag meeting. This is my estimation. Yeah, this is my information to in the room. And okay, so as the editors and here are the number of comments, but running sometimes. So could you back to the slide number 4?
Slide number 4. Okay.
Diagram topologies. Yeah. Let me clarify at the topologies that.
So we are running a L2 service from the DUT to R1.
Yeah. So the.
Yeah. So and in the DUT we are configuring the Y1731, Y1731 performance monitoring, and the traffic is sent bidirectionally.
Yeah,
layer 2 traffic.
Maybe you should describe the terminology or the architecture diagram defined in the Y.1731, such as MEG, ME, or the MEP. So at this topology, backing of such kind of the functionalities as defined in Y.1731. so that maybe at Ethernet OM is running on the
Okay.
ME maintenance entities and the map. Maybe DUT is one of the map,
Okay.
but and I don't find any word map in this draft, so that makes me
Okay.
confused.
So actually, this was, I agree with your point because, UpMap, because this was benchmarking, so we are defining the parameters. So that's why we define in the topology, we are running performance monitoring from the DUT to R1. So the UpMap portion is missing. I agree it because since, the circle of reference or the point of interest was on the benchmarking of this Y1731. That's why we focused on that. So definitely the UpMap, we will be defining it because obviously we'll be running performance monitoring on UpMap.
Anyway, if the study group 15 ITUT review this document, and maybe we should understand maybe where ME is located, where map is located, or something like this. This is must be the required, and yeah. Otherwise,
Yeah, we'll just UpMap, right? That will be defined as because this is understood because that was the, that was because it's understood that when you are running a performance monitoring, it's self-explanatory that it has to be run on an UpMap. So that's why it will explicitly mention that.
okay.
It's noted. Yeah.
And
Thanks.
another high-level point and the comment is, could you back to the slide number 3?
Slide number 3.
Slide number 3.
Thank you.
Yeah,
They're
this
not
is 5.
numbered, I'm sorry. Is this it?
Sorry, slide number 2, previous one.
No.
No,
Hang on a second.
number 2, slide number 2.
Slide number 2. So this one?
Right.
Okay.
And so 3 Barrett and yes, it's true that how to use over the different services and that's where ITUT does not define anything about how. Yeah, Windows 7031 G.8013. Yeah, now we can say it G.8013 is more present word. Of course, Windows 7031 is applicable, but okay, and G.8013 and it's only define the mechanism and how to use it. It's out of scope, but
Because
I would like to point it out in MEF, MEF 35 that defines the service OM implementation agreement that is applicable to the end-to-end Ethernet service, how to use the performance measurements and such kind. Yeah, so the point-to-point service, and so how to use the performance measurement, and the MEF defines how to use. Yeah, so yeah, a good example is shown in that document. So maybe this should be a good input, and if you proceed and document here, and so in principle, and
1 second, Eugene. So what is the point? I mean, because as we defined, ITU is just mentioned the stack. Okay, these are the counters used. This is how the protocol is.
Yeah.
But the service, what is the service? How to run on this service is not mentioned there.
good example is a MEF defined MEF 35.
Okay.
Yeah, that's what
Okay.
you should
Very
read
good.
it. Yeah, this is a good example.
Okay, we'll look into
And
it. That.
And
Thanks.
maybe as long as I read this document and the slides as you presented, maybe here we have some specific requirement. Is considered such as HA or the scale or SOC, and maybe this is very specific to the in this room, in this working group. So I would like to recommend and how you should clarify more in this document. So maybe this is very specific to the IETF benchmark testing, and that is different from MEF 35. So and it could be helpful, and maybe so if all of them I said we make clear, make it it's a very good work working here. Thank you.
Yep. Thanks.
Jay Karthik.
Okay, Jay.
So then definitely a very useful work item here. Assuming the working group is going to adopt this. one question, and again, this is not a challenge, just trying to understand, we are focusing extensively on ITU's Y1731. This is the superset of the IEEE's 802.1AG. Just want to understand why, the focus is with ITU and not so much, on the other standards body.
I can answer to you easily. IEEE, as you say, 802.1AG, does not define the performance measurement OM tools for the performance measurement. They are only to the CCM and the loopback and the request. So performance measurement is mostly developed by the Y.7031, this is 813. Yeah.
Thanks for that, UG. If that is the case, can we clarify saying, Y1731 is the superset, and so any connectivity fault management of 802.1 AG is implicitly getting covered here?
Yeah, that we can, because as Eugene mentioned that, because UpMap, as we didn't explicitly mention that, we'll definitely mentioning that this, because on the UpMap only we can run these services. So that will be mentioned explicitly that.
And then lastly,
yeah,
UG may have touched on this as well. The benchmark parameters at the MIP and MEP may be different. Perhaps we need to add some additional use cases for the intermediate points and the endpoints as well.
Jay, I would like to add on that, because intermediate points, endpoints, it's different from Y1731, because Y1731 covers only SLM, DM, and LM, loss measurement. So, and then link trace, this one, because link trace, that is where you are talking about. I understand that link trace where you're the intermediate point. That we'll look into it. We will see that, because we concentrate on the performance monitoring, because we clearly mentioned that. What you are touching upon, I agree that, because coming on to link trace where the intermediate point, but to benchmark that, we'll look into it, because that is beyond the scope of this draft, because we covering the performance monitoring only here, because that defines link trace and all, but that can't be, be a part of this at present. Let me see, I'll get back to you. Thank you. Thank you, Jay.
Thank you.
Only ma'am.
All right.
Thanks, Eugene, for the comments.
Good. So you've got lots of feedback on this one today, Sudhin. I think.
Yeah, it's wonderful.
Yeah. It really makes it. You can see it really makes a difference when we've got some Y1731 expertise in the room.
Yeah, that's wonderful, Eugene. I mean, it was a wonderful discussion. I mean.
So
Thanks,
good. I think we'll. Given that we're still waiting for the liaison, and so
I'll
we'll
wait.
close on this one and move to the next.
Yeah.
One question I'd like to ask is, where is the blue sheet out there? You've got it. Okay. Has anyone here, like Matt Mathis, not signed the blue sheet?
The limit time within the time.
Please bring it on over. And two folks here have not. All right, so we've got that covered. All right, I'm finding the other slide deck here quickly. And we've got a solid 15 minutes for this, Sabine, so don't worry.
Ramki is also there. Ramki. Yeah, sure.
Yeah, it's going to be a maybe, I think. And the clock is ticking. All right.
He's saying you stand between, 11:30 and lunch, so, yeah. Really? Really?
Or you could just watch the hour-long presentation and then do our Zoom from yesterday.
Ouch.
No, it was a good presentation. So this is about IETF RFC, that is RFC 7432, and actually this we presented in two drafts, like benchmarking of PBB EVPN and EVPN. Then the community told to, since the BGP and the signaling is same, so we have to merge this two into a single draft. So we have merged this two into a single draft, and that's why we are benchmarking 7623 and 7432 two RFCs into this, benchmarking into this particular draft. The scope is, can we go to the first slide?
Oh, sorry, yeah.
Yeah, thank you. So this is about EVPN, because EVPN is now widely deployed in the provider network, because it is going to supersede the VPLS. Those who being the provider, you know that VPLS, you cannot have a multi-homing with both sides forwarding. So here in EVPN, you can have both sides forwarding, and you have a load balancing. A lot of features are there, and it is coming up, and with lots of flavors. EVPN with lots of flavors are coming up. So it is deployed in data center with EVPN VXLAN, and in the provider world with EVPN MPLS. So the two different flavors, it's widely deployed, and many of the services are getting integrated into the EVPN. So that was a motivation that, so it was coming up. So we were testing it. So it was a requirement that we have to define certain parameters to benchmark this particular protocol, these two RFCs. And that will help in interop, as well as the end customer, the provider customer will be getting, they can measure, and they can pull out the statistics of how each box is behaving it. So we are defining a certain parameters to that. Can we go to the next slide? Thank you. So comments from the previous IETF is like from Iftikhar, so there's like ARP and ND scaling, so he wants to add it. So ARP and ND scaling, that is added. And one comment we received is we should not depend on the DUT CLI for the count, MAC counting. So that is taken care. And again, the high availability should be mentioned explicitly, that zero packet loss in the ideal case. This 3 comments we received from the previous idea. Can we go to next? So this is a topology wherein the DUT is working as a multi-homing, and we have the DUT, that MHPE2 and R1 are running in EVPN. So we are performing the test in this DUT, which is working as a multi-home P. Yeah.
Hey, Jacob Rapp, just have a quick question.
Yeah, Jacob.
So you mentioned the SP service provider use case, but also the data center use case. Do you plan on, are you planning on addressing both of those use cases, or just that service provider use case?
Jacob, we are, I mean, this protocol is used, as I said, let me be very clear on that. This protocol is widely used in provider as well as in data center in 2 flavors. In EVPN VXLAN is used in the data center environment, EVPN MPLS in the provider. So we are benchmarking EVPN as a protocol. So we are defining certain parameters to benchmark this.
Okay. So then if that's the case, then I don't think that just a one connection to the DUT is enough, right? Because it's not a non-existent event that you have in a data center, everything all of a sudden come up all at once.
Yeah.
And then all of a sudden you have this flood of everything, and one interface isn't going to cover.
Okay, because this is, I mean, this is, this topology is built on, in a provider environment where we are running, which I've clearly mentioned that this will be running an active-active scenario to SCE, and this is having an MPLS connection. That's why I mentioned RR and the provider router. The P is a provider router. So this is emulating a provider network. So the DUT, what we are performing this test is a vanilla EVPN. So it's not a EVPN VXLAN. So the vanilla EVPN, that is our RFC7432, we are benchmarking it.
Okay.
So that is, I hope I clarified it. So in the sense, let me clarify that we are not benchmarking, EVPN VXLAN in the data center environment.
Okay. So maybe we can put the note on that list then in scope for consideration.
I'm sorry. Yeah.
Maybe you could add a note that's in the
Definitely.
considerations or scope.
Yeah. We'll definitely, add that as a point. We'll definitely. Thanks for the comment. So can we go to the next slide?
Could we encourage you to maybe consider the data center use case? I'll go there.
Yeah, I mean, because since it's deployed and we want the customers in the provider as well as, because this is the standard technology. So this is deployed in the provider as well as in the data center as a EVPN VXLAN flavors.
Right. So you keep saying, to me, I keep hearing 2 things. You keep saying you're covering everything, but then you say you're only covering service provider.
No, I'm telling the protocol is widely deployed. I'm not covering in this draft. I'm benchmarking only the EVPN. I hope I clarified it. Well, so if you want to add the data center use cases, then that is welcome. We'll look into it. That's what I replied to Jacob.
So it's really a data center topology.
Yeah, this is not the, Sarah, I'm clear, because this is, we defined this in a EVPN in a provider environment. So this topology is not covering the data center. So if he says you want to add, definitely we'll add in the subret, because this topology is not suitable for a data center. So we have to add.
Let's take another question.
This is Avinash from AT&T.
Yeah.
Probably like from the service provider perspective, like MPLS is only encap difference within the data center, right? So in the data center, so VXLAN encapsulation probably. I think you are covering more from the EVPN control plane point of view.
Control and
yeah. But referring the RFC 7432.
Correct. Correct, Avinash.
And also, you're mentioning about the scale. Are you considering the route scale as well here?
Yeah, that automatically comes to the route scale. That's a max scaling is also there.
Oh.
That's a route scale. It is there. It will be coming. I'll come to that point.
Oh.
I'll come to that point.
Thanks.
Because, so does that answer my question, Sarah? So this is a topology is now it's purely on provider. So that topology I need to add it because that comment I'll definitely work on it. So I mean, can we go back, Al? Thanks. Sorry. So these are the parameters we have defined. 8 parameters we have defined to benchmark this protocol. That's one is the MAC learning, then the MAC flash, the MAC aging, the high availability, ARP and ND scaling, the scale, convergence, and the SOAP. So these are the 8 parameters we are defining this to benchmark this protocol on a DUT. Yeah, next slide. Yeah, thank you. So this is MAC learning. So we are measuring the local, time taken to learn this, X, XK or the X MAC into the DUT, as well as the time taken to advertise this X MAC to the remote, and from the time taken from the X MAC from the remote to register in the local. So the 3 areas we are covering in the MAC learning parameter. Can we go to the next slide? MAC aging is we are measuring the time to age out this per X. X is a scale, so it can be 100,000 or 200,000. So that once this traffic is stopped, that's the time is measured, and we measure the time taken to withdraw this routes. After the aging, this has to be withdrawn from the remote routers. So that is also we are measuring. Can we go to the next slide? So the MAC flash is we are simulating a provider failure. It's a link failure. We are simulating it so that we are measuring the time taken to flush it from the local CAM table or the MAC table, as well as the time taken to withdraw these routes from the remote machines. So in case of a PEC link failure, that is a common scenario in a provider world where the link fails. Can we go to the next slide? So this is a new addition wherein they use MAC. In EVPN, one thing is like if an ARP comes to a gateway, it will learn the MAC as well as the IP. So it will be advertising the MAC and IP. That's called MAC plus IP. So it will be storing the MAC and IP together. So that is a benefit of EVPN. So that we are scaling up. We are sending X ARP to the gateway and finding out, finding the learned rate. So the X MAC plus IP is getting advertised to the remote peer. So that is where we are scaling for ARP as well as the ND for the IPv6 plus MAC. So that is, and high availability is nothing but the routing engine failover. So there should not be any loss of, any routes. Its a session should not reset. No flushing of the routes. That is the expectation. Ideally, there should not, ideal case, it should be 0 packet loss. That's the expectation. So next slide. The scale. So we are scaling. There are 2 kind of scale parameters we are using it. We are scaling the EVPN as well as we are using the MAC scaling. So it's kind of a two-dimension scaling. We are scaling the number of instances, EVPN instances, as well as the MAC addresses. So and we are measuring the time taken to learn all this MAC, and in this scale, what is the performance we are looking at it. Next slide.
Sorry.
Oops, okay.
Here we go. I was mostly trying to also check where the heck you were.
I'm sorry.
Good. Please continue.
Yeah, thank you. So the convergence is, so we are in a scaled environment. It is scaling into a N instances. So N can be several hundred or in the thousands of instances with X. X is a term we generalize. So it can be 100K MAC or 500K max. So and we flap the link, the core link, or we flap the BGP to measure that time period for flood which is happening towards the core. So that is one of the key parameters. So how fast is it learning? It is converging. The BGP is converging and learning and reducing the flood. That's where this test case is about. Yep, Jay, you have a question?
Yeah, Jay Karthik, BMWG standardized another basic BMWG convergence benchmarking RFC 7747. Are we using that? Because when you talk about EVPN, the underlying protocol is of course BGP, right? You don't have to reinvent some of BGP parameters. At the very least, we got to be referencing that. So is that the plan?
Because this, one of the IETF RAM case was also mentioned about this BGP. We referred that with because that time itself we referred that, and which based on that we have written this. And in fact, the one of the 2889, I believe, for the max scaling, that is one of the RFC. That also we reference, and we have referenced that in explicitly we mentioned the RFC in the Mac learning this one. But in BGP we didn't explicitly mention it.
So, I just searched for 7747.
No, that is not explicitly, but we referred that to do that because this was comment was given by Ramki. I think in Buenos Aires. Buenos Aires, yeah.
Thank you.
Yep, thanks, Jay. So next slide. SOAK is running for 24 hours with the traffic, with scale, with scaling the n instances. N can be several hundred or thousands of EVPN instances. So, the next step.
Right.
Yeah.
So who's read the draft? 1, 2, 3, 4, 5. Good. How many folks would like to see this by a hum? How many folks would like to see this adopted as a working group draft? Hum now. How many opposed? Okay, that's pretty good. All right, so we have to take things like this to the list, but we can say that there was support in the meeting. There was one thing other that I wanted to do. Well, it's obviously sort of predicated on resolving some of the comments that came up today, particularly with respect to the scope and the coverage and the references and so forth.
Yeah, one comment.
Quick comment at the end.
Yeah, Avinash.
Quick question. This is Avinash from AT&T. There are a lot of folks outside trying to implement EVPN Type 5 prefix routing as well. Is it possible to extend this draft to include Type 5, or is it just targeting to scope Type 2 MAC plus IP?
Yeah, Avinash, that's a good question because as you are aware, right, because that is spin as a different draft by Rabadhan, Jorge Rabadhan. It's adopted by IETF now. So to that, we have to either change the scope of this draft to incorporate that. So, but since it's widely deployed in, in this, mostly this Type 5 is deployed in the data center. So as Jacob was also pointed out that there's definitely a room for, adding that. So just give us some time. So
sure.
Definitely, because since he has also pointed out, Sarah also pointed out this DC world. So we have to plan, like we cannot just, we have to plan, and topology, we have to define it, and just give us some time. We'll definitely look into it.
No problem.
That's a good comment.
Yeah, thank you.
Yeah.
Thank you.
Can you give us a good, concise statement of what you'd like to see added to the scope, Archana?
There is another new route type phi where you can advertise a prefix in EVPN as well, like how you advertise prefixes in 2547 L3 VPN.
So route advertising like 4547. You would like to see that in scope?
2547, equivalent to 2547.
Okay.
So there is a separate draft on route type phi where you can advertise a prefix in EVPN as well.
Yeah, Avinash, definitely.
problem.
That's
Take
a
your time on
good.
that,
That's a good comment. Just let's work on it.
Sure.
Yeah.
Let's put that on the list. That's really important to make
Okay.
the scope of what we're adopting nailed down.
Okay.
Correct.
And of course, one of the things we have to do always is we need to discuss, chartering to pick this up with our new area director, Warren. And so, good. Sudhina, I'm going to thank you for your presentations, both presentations today. We're done at this point with that one. One thing I want to quickly get to is before we pick up Ramki here.
We have 1 minute.
Yeah, I know, but this is important. It's all important. Let's see. Right here. Joel, you're leaving us. Yes. And it's not, it's something we're happy to see that you get your sort of a portion of your life back. Please come on up, just so that everybody can see you today. This has been happening all week, but as a working group, we definitely want to thank you for your contributions. And it turns out the data tracker makes it really easy to do that. I've got a list of all the RFCs here. The recent ones in the data tracker that you've shepherded us through with the IESG, and of course we really appreciate those. And there's two not listed here because they're not in the RFC section. They're way up here in the more recent graph space.
We have them in the editor queue.
Yeah. And the editor queue. That's exactly right. So on behalf, and there's one other thing that I want to thank you for. When you first took over, you said, Al, what happens if you get hit by a truck? Get yourself a co-chair. So we can thank you for Sarah as well.
Yeah, I'm actually kind of interested in business continuity because weirdly, I'm neither the most important nor valuable piece in this whole chain. So I think we've established that, but it's good to build survivability into our processes. It also helps if they actually work when you have indifferent chairs or ADs, because we're not all perfect, nor do we have enough attention. So distributing the workload is pretty important. Yeah, I can't claim to have been as useful nor as long a contributor to this activity as Scott Radner.
None of us can.
No, we all walk in his in the path that he carved. So, but yeah, no, it's been fun. And I think we've done some important stuff, and it feels like we got something done. So
it definitely is the case. So thank you from all of us.
I think that's the only time he's ever going to appear on a video recording of BMWG.
So Ramki, you've got like 30 seconds. 30 seconds.
Literally 30 seconds, man. You're standing between us and beer.
So at NFERG, we're taking a broader look at microservices, and also primarily the biggest challenge this microservices is introducing is how do you deliver low latency? I mean, it's across the board, enterprise to IoT, and also emerging NFE applications. That said, to deliver the low latency, hardware acceleration is a key component. And also we're taking a much broader look, not nailing hardware acceleration to a particular component, but how do you define as reusable Lego blocks? Classic example, for example, we talked about AES-NI or security acceleration, or Intel Quick Assist, right? Can you use it for applications, for example, SSL or TLS? And can you use it for IPsec protocol termination NFV? And can you also use it for storage, right? For example, there is storage encryption happening, right? Decryption. So how do you build these reusable Lego blocks? And also a key ingredient for us is we need this to be vendor agnostic. We don't want to be nailed this to particularly just Intel, right? We want to be across other vendors such as ARM. Right? So that's the key area we're looking at. Tying it all together, bringing to the right immediate implementations to BMWG, and also, as part of achieving this whole ecosystem, what we do in terms of SLA monitoring. For example, as we can see, as we split these components in terms of, processing in databases, we see RDMA coming up as a key networking, component of the ecosystem. And how do you deliver RDMA? In Ethernet world, it'll be something like ROCE, which is RDMA or converged Ethernet, not InfiniBand. So how do you really make it happen? These are the pieces we're putting together.
Ramki, are you finishing your presentation today in the second NFERG session?
I hope so. It'll take like 10 minutes, possibly.
So please, we're going to probably push him to the end of that agenda. I'll speak for Diego. But come and join us in NFERG at 3:30. 3:30 session?
Yeah, 3:30 session.
Yeah?
Yes.
Thanks, folks.
Thanks to all our
Thank
note takers. Thanks to our Jabber scribe who's running out the
Fantastic
door.
job.
Thanks to everybody who attended for the first time. Remember, this is easy to join. Thanks, Chin, for the blue sheets. Look at this, we got 31 people here today, and about 9 on remote. That's pretty good. That means we'll get a decent-sized room next time again. So thank you, everybody, for attending. And thank you to my co-chair, and thank you to our new AD.
A lot better. Yes. Hey, how's it going? I like having a little fun. Yeah. I really enjoy it.
Pleasure, Samuel. We'll talk.
From Cisco and yes, Samuel, very, very good job. Congratulations. You guys in there, yeah? Yeah? 320, whatever, yeah. Right now, you did?
Yes, thank you, Sarah.
All right.
This went off very well.
This is, I think, one of our better ones, huh? Oh, I think they're always fun, but this one was really interactive,
Yeah.
which
Oh,
is nice.
the only other thing I wanted to mention is if you're the one who grabs the slot next time, I want to put in